In this part we'll be talking about a circular motion, so we'll introduce a new system which is the angular system. So what do we mean by angular system and how can we express the position, the speed and the acceleration in this case? First, in order to talk about the angular system, so we take a point M which is assimilated to a particle and moving along a circular trajectory. So here we are talking about a circular trajectory. This is the point M, it's moving along a circle. So what do we mean by angular system? It's a system where the center here, we take for example the center of the circle, it's I, and O is the origin of trigonometric circle, where we know this will be the positive direction of the trigonometric circle, and in the other part we'll have the negative direction. Now how to express the position? In order to talk about the angular position, so it's the angle, so from its name when we say angular position, so it's a position which is given by an angle. This angle is called theta. For example, here if I want to find the position of the point M, I can say for example that M is at 45 degrees from the making an angle of 45 degrees with the horizontal, and هيك بقدر أعرف we put 45 degrees and then I can put the point M. This is what we call the position or the angular position of the point M. So we knew it from the angle. So this angular position is given by theta, and it's in terms of t, since each time the point is moving on the circle, then the angle is changing. Now as for the angular speed, so the definition we want to change the angular speed, it's equals to the variation of the position with respect to time. So if we want to write it for example as variation of angle with respect to time, variation of angular position, it will be delta theta over delta t. And if we want to take a very small interval of time, then in this case it will be d theta over dt, since we took a very small interval of time, and this is what we call the derivative, so it's equals to theta prime. Then we know now that the angular speed is equals to the derivative of the angular position. So it's given by theta prime, derivative of theta. Same thing if you want to talk about the angular acceleration, so it's the variation of the speed with respect to time, and for a very small variation we'll have d theta prime over dt, and this is what we call theta double prime. Then its unit is in radian per second square. Here it's in radian per second. So this is for the speed, angular speed and angular acceleration. Here we have an application for this part. So لنعمل هيك revision. We said we have theta, this is what we call angular position. It will be given in the exercise, for example here. And then theta prime means the derivative of theta, this is what we call the angular speed, and then its derivative, the derivative of the speed, this is what we call the angular acceleration, so theta double prime. Now we read the question. We have an object assimilated to a particle which moving along a circular trajectory with radius r equal 2 meter. So the angular position is given by theta equal in SI unit. Verify that M is not at t equals to 0, is not at O, it's not at O, at t equals to 0, it's not on the origin. In order to verify this question, we must find means at t equals to 0 the position. If at t equals to 0 we have theta equals to 0, then this means M is here, it's at the origin. But the question is verify that M is not at the origin, is not at O. So here we'll find theta at t equals to 0, so only by substitution we have at t equals to 0, theta 0 equal, we'll have equal pi over 4 radian. This pi over 4 radian, then it's not at the origin. Now can we place it? So yes, we can place it on the figure, on the graph, but we want first to convert this pi over 4 radian into degree, and then we can place it on the figure. How to do it? So each pi radians equals 180 degree. Then the pi over 4 radians how much? And then we do the cross. We'll have theta 0 equal 45 degree, and then we can place it on the figure. Here is the point M. So from here we take 45 degree in the positive direction and we put the point M. Now question number 2, and the question is calculate the angular speed first at any time, and we want to deduce it at t equal at certain instant. Now at any time, this means the derivative. So we did the derivative of theta, knowing that we had theta equals كان معنا إياها بالgiven is equals to 2t square and plus t plus pi over 4 plus pi over 4. Then this was the given. We do the derivative, so by deriving 2t squared is of the form ax to the power n, then it will be 4t, and t it will be plus 1. As for pi over 4 it's a constant, then its derivative is 0. Now deduce this angular speed at t equal 1 second. So we substitute here, we substitute t 1 second, we'll have theta prime equal 5 radian per second. Now in order to find the acceleration, the angular acceleration, we must do another time a derivative of the speed, the angular speed. So theta double prime is equal to the derivative of theta prime. By deriving 4t it will be 4, and the derivative of 1 it's 0. So this will be the angular acceleration.